Hello, everyone, and welcome to our June webinar. Today, we're going to be going over 10 tips and tricks that users of the base version of Global Mapper can take advantage of. And yeah, I'm super excited to get into it. Today, I'm joined by my colleague, Gus Cook. Hello, Gus. How's it going?
Hello, Meg. Happy to be here. It's going very well.
Nice. I'm glad. Well, before we get started, I did want to do a quick icebreaker. So, in both of our roles, we speak with a lot of users, and I figured I'd pose the question, what's the coolest thing you've seen accomplished with just the tools and the base version of Global Mapper?
That's a great question, Meg. I know that, we see a lot of varied use cases from different user groups from all over the world in terms of pro and the standard features. Let me think off the top of my head, a couple neat use cases. One of them that comes to mind was relatively recently. We spoke with a user group that was connecting to online sources, so a web map service, and they were downloading aeronautical charts. Then they were exporting those aeronautical charts to a file format called CADIRG or CADRG, which is a military chart format. And then they were loading those into the actual cockpit interface of their Black Hawk helicopter. And they were using those for navigation. So that was a pretty neat one. Let me think. Well, other good use cases. Just recently speaking with another user group who had a number of sea ice thickness charts that were not georeferenced. So what they were able to do is, because they were overlapping of the same area, they georeferenced one of the charts, they saved the ground control points for that, and they were able to batch script georeferencing all of the 100 or so overlapping sea ice thickness charts. And then the really neat part is they were able to create an animation by toggling on and off those layers to show the change in sea ice thickness over time. So those are just a couple use cases that come to mind, things we've talked about recently. Why don't I pose the question to you? Do you have a particular favorite use case?
That's a great question. Well, first of all, thank you for sharing both of those use cases. That's very cool. Um, yeah, I guess I get involved with the blog creation process, so I get to see some of those like smaller scale workflows that we publish for users. And one of my favorites that I've noticed is the 3D printing one. I think that it's just so cool, like how much you can do with, you know, that and like exporting and having these 3D visualizations that you can kind of hold in your hands. It's quite cool. So yeah,
Yeah,
awesome.
love the tactile use case, definitely.
Yeah, it's awesome. So getting into the webinar format for our attendees, you're in listen only mode, so please use the questions or questions panel to ask questions throughout the event. And if you are unable to stay with us for the entire duration, you will receive a link to watch this session once it's on our video collection on our website. So definitely keep your eyes peeled for that. And then we've attached some handouts. So we've got some upcoming events and training opportunities in one of them. Another one is some like easily accessible resources for users. And the final one is just like a good recap of Global Mapper and what tools are available in it. So definitely download those before we leave today so that you don't lose access to those. Let's get into it though. So we've got our agenda right up here. And I guess let's kick it off. I'm going to share the screen and I'm going to kick it off. Thank you.
So for our first tip, we're going to talk about the ability to use our Combine Compare Terrains tool to create a grid representing the difference between one elevation grid layer and another elevation grid layer. And we can use this to perform kind of an evaluation of change over the time period that has passed between the initial data collection and our second data collection. So we can already get a visual indication of some of the changes that have occurred just by toggling these layers on and off. It's apparent that this digital surface model from LiDAR data collected in 2024, there was a lot less vegetation than in this initial data collection in 2016. But we're going to actually create a raster surface that represents the locations of this change, both positive elevation changes, so increase in elevation, as well as negative elevation changes. So that would indicate maybe a particular grouping of vegetation or a building was removed, for example. The first thing we're going to do is create a custom shader that's going to represent this difference between these two time series of data collections a little bit better. So I'm going to go up to configuration, and then within configuration, shader options, and I'm going to create a new shader here. And I'm going to name this shader difference. I'm going to add a couple values. The first of which I'm going to add a negative value. I'm going to give this a bluish color here. I'm going to add a second value. We can keep this at 0. I'm going to give this a white color. So that's going to represent any location where little to no changes occurred. And lastly, I'm going to add a third increment at 5 meters. Let's give this a red color. And that would indicate any kind of positive change or increase in elevation for a particular area. So we can name this difference shader. And I'm going to check this option to blend our colors. So the shader is going to be applied at a gradient. It's not going to need to be exactly at that increment in order to have that color applied to it. All right, so now that I've created my custom shader, I'm going to go ahead and create my difference grid. I'm going to go up to terrain analysis, combine compare terrain layers. And now within this dialog, I'm going to choose, we have a number of different operations available. We can add our terrain layers together. We can calculate the average between them. We can choose to use the minimum or the maximum elevation from the two input layers. But I'm going to choose this option, subtraction difference signed. If we chose unsigned, that would be the absolute difference. So not accounting for whether it was a negative or positive change. We're going to choose signed because we want to account for whether it was a negative or positive change in elevation between the two grids. I'm going to subtract the 2016 layer from the 2024 layer. I'm going to let this run here. And once we've generated our output combined grid, the last step in this process I need is to apply my new custom shader. So I'm going to go into layer options for that particular layer. And I'm going to apply my new difference shader here. Maybe I want to turn off hill shading. And what I've done is actually save a couple of views within this workspace file. We have the ability to save a particular visual extent, and we can name these, save them within the workspace so we can quickly jump back to a particular location without having to search for it. So I'm going to go to the View drop-down menu, restore a named view, and let's go ahead and first look at this new housing view that I've saved. We zoom in here, we can see that the red would indicate a positive change in elevation between 2016 and 2024. Looks like we have some new buildings that were built in the interim between these two data collections. Another quick example, I'm going to restore another named view here, and I'm going to select this reduced vegetation view. I'm going to zoom over there. You can see all this blue here indicates that these are areas where the elevation has decreased in 2024 in comparison to the 2016 data collection. And this would generally indicate that we have a lot less vegetation in this particular area. And within this particular example, we are looking at kind of the above ground features, but a very common use case for this tool would be more so related to a bare earth digital terrain model where we are maybe evaluating how much material and what material has been removed and added to a particular location, maybe in a quarry or a mine, for example. So to give us a basic overview of that first tip, we're able to take two elevation layers that were collected at different dates, and we can evaluate the change over that elapsed time period by subtracting one from the other. Alrighty, so for our second tip, we're going to talk about some contour creation options that you may not already be familiar with. Of course, we can create these lines of equal value, equal elevation value, our contours, but within that same dialog, there are some additional options to create other derivative outputs. So we're going to talk about those as well as some general tips and tricks in terms of improving the visual appearance of your contours, and also just generally how to create the type of contour that you would most benefit from. So I'm going to go ahead and use this elevation grid layer as my source. I'm going to go up to my analysis toolbar, create contours. Within this dialog, there are a couple options to note. The first of which I'm just going to talk about quickly is our resolution. So the resolution of our contours is derived directly from our source elevation grid data. And one thing to note is if you have lidar derived terrain data that you're using to create contours from, this can sometimes lead to slightly more jagged appearance of those generated contours just because the underlying grid is at such a high resolution already. So one thing you can do if you want more generalized, some would say less accurate, but they will look better in visual appearance, we can adjust the resolution at which our contours are created at. So I'm going to just slightly reduce the resolution that our contours are created at to 2-meter resolution. A couple other options here that I wanted to address that you may not be aware of. We have the option to create ISO height areas. So rather than lines of equal value, it's going to create area features or polygons representing each increment of a particular elevation value. So this can be potentially useful if you want some kind of area features and you want to perform an analysis to maybe determine which elevation range does a particular point fall into, for example, would be one potential use case of that. A couple other options we have here, the ability to find local peaks and depressions. What that's going to do is look for concentric closed contours around either a lower area or a higher area within the elevation. And so we can identify these and create points at these kind of localized depressions and these localized peaks. Lastly, we have this option here. I'm actually going to keep this one checked. The ability to create spot elevations at my minimum and maximum encountered heights within my source data. So as the name would indicate, we're going to create a point feature representing the highest elevation within my source data and the lowest. I'm going to go ahead and run this, and we're going to create 5-meter contours. This example here. I'm going to just quickly rename this layer to 5-meter contours. Alrighty, so we've created our contour layer and we also have our spot elevations contained within it. Something that I always like to do with contours is to split them out into separate layers. We can do this by right-clicking on my contour layer, and then the option to split based on an attribute value. Let's choose feature type. Now we have a group within our control center, and we have our intermediate or major and minor contours as well as our spot elevations in a separate layer. The last thing I'm going to do is to apply the shader that is currently set as my global shader to my contour lines to create kind of a neat visual appearance to them. So I'm going to right click. I can actually select and initiate the options menu for multiple layers by holding shift, selecting all 3 of these layers, right click, options. Now within this options menu, I'm going to go to my line styles. I'm going to select this option to use the same style for all features. And then from my style drop-down menu, I'm going to choose elevation solid. I'm going to click OK. I'm I'm going to apply that styling. Where did they go? They disappeared. Well, if I toggle on my base map here with just some imagery to give us some geographic context, and I turn off my underlying elevation data, we can see that we now have our currently specified Atlas shader coloring my contour lines. So for tip number 3, we're going to continue in the same contour workspace. And we're going to talk about a new feature that was added in version 26, and that is our command search tool. So let me go ahead and initiate command search. And this dialog can be docked anywhere in the interface. I tend to like to dock it right in this kind of control center area here. And now I can quickly toggle between my control center and my search dialog here. And what this allows me to do is quickly search and find any particular function or tool within Global Mapper. Maybe I don't remember exactly what menu I need to find a particular tool. For this example, maybe I want to apply some additional post-processing to my contours. Maybe I want to smooth them a little bit. So just kind of removing some of those more jagged features and making them slightly more generalized. And I can't remember exactly where in the interface I can access that tool. But what I can do is within this search toolbox, I'm just going to type in smooth. We can see that this smooth selected lines and area features is available directly from this search dialog. So before I do my smoothing, I'm just going to select all of my contour lines. I'm going to select all these in the control center, right click, and then I'm going to choose select all. And then I'm going to jump back into my search toolbox results. Let me zoom in a little bit to give us an indication of what we're actually doing here. And what I'm going to do is just double click this to run the smoothing. And as I can select this multiple times, and we can see each time we're able to perform an additional adjustment, more smoothing to our contour lines. So in summary, the command search is a new feature that was added in version 26, and it allows us to quickly access a particular function or tool that we may not remember exactly where it is located within the UI. And this is going to be increasingly more useful as we add more and more new tools and more functions to future releases of Global Mapper. For our 4th tip, we're going to talk about some new functions that have been added to the Path Profile tool. Yeah. The Path Profile tool allows us to quickly take a crosscut of any kind of 3D data that we currently have loaded. So that might be terrain data, like in this example. We can also do the same with a Global Mapper Pro license for lidar data. One thing that may have, you may not yet be aware of is the ability to initiate one of these crosscut views or profile view from an existing line feature. So we have this existing line feature here. This is some bathymetric data. This is kind of the continental shelf we can see on the edge. And then it flattens out, and we have this line that's generally following that shelf here. We're going to select that. I'm going to right click, analysis measurement, path profile. So we've created a profile following along that line. And we can see as I toggle to the left and right, we can see my current location on the profile there. So once we have this profile created, there are a couple new tools and functions within here that would be definitely worth pointing out. The first of which is the ability to apply a shader to my profile view. Just to give us a nice visual appearance, if we wanted to add this profile view as a map inset object to maybe a map layout that we want to create a printed product from, that might be a useful use for it. It also will give us a good indication of, in comparison to the shaded values in the 2D view, how does that relate to the values we're looking at within the path profile view. The next function that I wanted to point out is the ability to edit the per vertex elevations of our existing line feature from within this path profile view. So before I do that, I'm going to open up my path profile settings. I'm going to go to perpendicular parallel profiles. And as you can see by my scale bar here, we're working at a pretty macro scale. You can see that we're working in multiple kilometers of distance. So I'm going to check this option to display a series of profiles perpendicular to the path that we initially created the profile from. And instead of using a length like maybe 50 meters, let's change this to kilometers. Let's try creating a profile, these perpendicular profiles at, let's say, 50 kilometers and see how that looks. We're going to keep our original vertices, and we're going to also sample a fixed number of times. So I'm going to apply this. And so we now have our perpendicular profile enabled. So we're able to quickly toggle through these. And once I've clicked once, I can actually use my arrow keys to quickly toggle through these. And that's one part of the process, is just to be able to visualize our perpendicular profile. Now what we can do is actually edit the existing line feature and the elevations contained within the vertices. So I'm going to select this option to extract lines and areas. Now I'm going to be prompted, do I want to edit the selected line feature? The answer is yes. So within this, we can toggle between each sample interval of my perpendicular views. And within that, we can adjust the relative location of each particular vertex. And I can go through as needed and perform edits and adjustments to the location of all those vertices. When I'm all done and I want to save those changes, I can just select Save Feature. And now we've adjusted the per vertex elevations of that existing line feature in a way that would have not have been very straightforward to do in the 2D view or the 3D view. So for our fifth tip and trick, we are going to talk about the ability to first create a custom feature type or multiple types, and then use the quick point creator to more effectively and efficiently digitize particular point features and have them be already assigned to a specific feature type. So the first thing we're going to do is create a couple feature types. We're going to go up to configuration. Within configuration, we're going to select styles and then point styles. I'm going to select to create a couple new feature types. The first of which is going to be called water service. And let's assign it a symbol. I'm going to go all the way to the bottom of our symbols here. And let's select this well symbol. That would be good for anywhere we can access a water service. I'm going to click OK to create that new feature type. And then I'm going to select a second one. Let me apply that change. And I'm going to add a second feature type, and we can call this sewer access. I'm going to assign this another symbol here. I'm going to apply that change. Alrighty. Now let's pretend hypothetically that we are going through this aerially derived imagery, and we are manually digitizing the locations of access points to our water service and our sewer lines, for example. And if we weren't going to use our quick point creator, we would have to manually adjust the feature type of each of these new points that we created. But using our quick point creator, we're going to be able to just quickly digitize them, and they already have that assigned feature type. So I'm going to right click here, create point text features, show quick point creator. And we can see that I already have my two feature types loaded in here, my water service points and my sewer access points. So if I want to create a water service point, I'll just select that. And let's say that there's one right here. We would just click that particular location. I can assign it to a layer called water access. And this is just a really quick way that we can digitize features without the need to adjust each one after we've made it and assign it the correct feature type. Maybe we want to switch to creating a sewer access point. Maybe it's right over across the yard here. I'm going to create that. We can add it to a new layer. We can call that layer sewer. access. So again, our quick point creator allows us to quickly digitize point features, and these point features will already have an assigned feature type, and that feature type might also include some default attribute values. So it doesn't just need to be whatever kind of symbols assigned to it. It can also have some contained attributes. So
All right, let's get into a quick Q&A. We had a few questions come in during those tips, so I'm going to jump right into it. So, someone is wondering, just out of curiosity, where did the data from the DSM for 16 and 24 come from?
Yes, that's a great question. So I will answer that question. I'm also going to answer the second one, which is also related to that first tip and trick related to subtracting the per cell values from one digital surface model to another. That data was derived from USGS 3DEP lidar data that I brought into Global Mapper. I created the elevation grids from all in Global Mapper standard. And then the second question we have here is something that I had initially thought about when I originally was able to obtain this data. And the question was related to could the reduced vegetation be related to leaf on, leaf off conditions, so the time of year? And this was the first thing when I accessed this data that I had assumed. But then I was able to look at the metadata from the source web pages and determine that both of them, the 2016 data set appeared to be collected sometime in the spring based on the date associated with it. And then the 2024 looked like it was also on a leaf on period. So my initial indication was that it was probably leaf on, leaf off, but it looks like they were both leaf on. So for whatever reason, it looks like they cleared out a lot of vegetation in that area.
Yeah, that's super interesting. Well, I think that takes care of our questions for this first part. So I'm going to move on and share a quick tip, a quick bonus tip, before we jump back into the other tips that Gus has prepared. And that is the training courses that we have available online. So we have some introductory courses for Global Mapper users and Geographic Calculator users. You can scan this QR code and it'll bring you right to the page with all of the courses we have available. And I definitely recommend it if you are always looking for kind of more self-paced training opportunities. This is a great way to get to know the software better. Our team works really hard on these courses, so it's pretty great. And that's my quick bonus tip for everybody. Oh, we're going to go back. That's a spoiler for later. And I'm going to share.
for our sixth tip and trick, we're going to talk about some of the ways that we can customize our control center. Of course, our control center is the dialogue through which we can interact and view all of our currently loaded layers. And there are a number of functions and features to customize this and adjust it to meet your current needs. The first of these little tips I'm going to talk about is the ability to reverse the order in which our layers are currently displayed. By default in Global Mapper, the first drawn layer, so the layer on the bottom of my 2D view, is going to be at the top of our list. Some people find this to be confusing. I'm personally so used to it that I find it to be confusing to reverse it, but we can reverse this if we need. I can right-click within the control center, and I can select this option to display layer list in reverse order. Now we can see that my top drawn layer is on the top of our list. This makes a lot more sense to some people. I'm just going to go ahead and reverse that back so that I don't forget. Another function, and this is new to version 26.1, is the ability to copy and paste a raster layer. So with this base map layer selected in the control center, I can Control C and then Control V, and I can actually copy a new version of that layer. Maybe we want to adjust or edit one of the layers, maybe resample that layer, and we want the other unchanged layer to be maintained within the workspace. We can quickly copy paste over a raster layer. So that can be terrain or imagery. I'm going to go ahead and close this copy. Another little tip related to our control center is the ability to automatically refresh a layer on change. So I'm going to select this option here. And what this would allow me to do is if any changes are made to the source file, which this layer is based on, those will be automatically reflected in the workspace when I load it in again. So maybe we are working on a shared drive where there's a new version of maybe a shapefile, for example. It has some updates to it. We don't need to re-import to see those new changes that have been applied to the new version of the source file. It will automatically be updated when we open up that workspace again. Lastly, one or two more things. The ability to group our layers together. So for example, we have our 3 kind of elevation grid layers here. I'm going to select all of those. I'm going to right click. I'm going to group, and we can just name this elevation. And then within that elevation group, we can actually create subgroups. So for maybe my source layers here, I'm going to select those, group, and then I'm going to add after my elevation group, sub, and then we can call these source. So within my elevation group, we now have a subcategory contained within it for my source elevation grids here. If we want to ungroup something, we would just select the group name. I would go back to group and then just delete the name. And now we have removed that particular set of layers from that group. So for a little bit of review, we talked about the ability to change the order in which our control center layers are drawn. We also talked about the ability to automatically refresh a layer on change to the particular source file. And we talked about some options available for copying and pasting a raster layer within the control center. And lastly, the ability to group and ungroup layers. For our 7th tip and trick, we are going to talk about the process to combine elevation grids that might have variable resolution. So it's very often the case that we might have a higher resolution terrain grid, and we want to combine this with a maybe lower resolution grid that's filling in some of the gaps for the data we might not have. But what we might notice initially here is that there is an obvious offset between these two grids. If I use my path profile tool here, we can get a better indication of that. We can see that very distinct offset. We don't want to maintain that when we combine these through export. So what we can do to fix this issue is to apply a little feathering to our inner higher resolution grid. So I'm going to go ahead and right click on my higher resolution elevation grid layer here. I'm going to go to options. I'm going to go to the feathering tab. I'm going to apply feathering to all 4 of our edges. I'm going to make that feathering border around 100 pixels. I'm going to apply that, and we can see that the visual transition is a lot smoother between those 2 layers. And we can use our path profile to get a better indication of that. Now, if we wanted to combine these, what we can do is select both of them, and we can export them both to the same file. For example, maybe we want to export to GeoTIFF. If we are combining 2 grids, I would typically recommend bilinear or bicubic interpolation to give us a nice, smooth output grid. For the second half of this tip, we talked about the ability to combine data. I also wanted to make sure I mentioned the ability to crop data within Global Mapper. So I'm going to go ahead and turn off that feathering that I had initially applied. And I'm going to turn off my lower resolution elevation data. I'm going to turn on this base map layer. We can see that the bounds of this base map, they don't line up exactly with my terrain. And let's say it's very common that we want all of our loaded layers to nicely line up with one another in terms of the bounds. What we can do is create a bounding box from my base map layer. So I'm going to right click on that layer. I'm going to go to the layer, VBox coverages, and I'm going to create a new vector feature, which I can select with my digitizer. And now with that vector feature, I am going to crop my terrain layer. So I'm going to right click on that terrain layer, options. I'm going to go to the cropping tab here. And I'm going to crop to my currently selected polygon. That way we're able to kind of quickly make sure that all of our layers are adhering to the same basic bounds. It'll give us a much nicer appearance. For our 8th tip and trick, we're making some really good progress here. We're going to talk about the ability to essentially apply the hill shading effect from an underlying terrain layer to an overlapping imagery or an RGB raster. So again, we might note we can toggle it on and off. We see we have this shadowing or hill shading applied to that underlying terrain. And that's what really gives it its 3D appearance within the 2D view. What we can do is apply that to this RGB raster, this imagery layer. So I'm going to go into the layer options for our RGB raster. And within this display tab, I'm going to check the option to texture map. I'm going to apply that. And if I open, we can already initially see the hill shading applied. And if I open up my 3D viewer, you can see we have this nice textured visualization where we're really getting the best of both worlds here. We have the texture applied from the imagery, and it's overlaid on top of the 3D terrain surface as well. We could easily export this to a 3D PDF, for example, or we can create a fly-through video. All we would need is a line feature representing our flight path. We would specify a particular altitude above our loaded data, and we could easily save that recording of our 3D view to maybe an MP4 file or whatever kind of video file you want to store and share it as. For our 9th tip and trick, we're going to talk about some new features that were added within a few recent versions to the Watershed analysis tool. Of course, the Watershed analysis tool allows us to create stream paths or likely places that water is going to flow along the terrain surface. What's been added in recent versions is the ability to use 3D vector features specifically as either obstructions or culverts to modify that stream flow. So in order to illustrate this, I have a line feature that would represent a prospective new culvert location. Culvert being a tunnel that would allow the flow to pass from here over to here where it may have otherwise been obstructed by the existing terrain surface. So first, I'm going to run my watershed analysis, and I'm not going to check any of these options over here to use my vector features to modify my flow. I'm just going to run it in its default state. And we're going to take a look at our stream paths. Once we've generated this initial watershed output and looked at our stream paths, we can look at the path that our streams have taken in this particular location. If we zoom to our specific location of our culvert, we can see that the water is going to likely flow and it's going to move down the road in this general direction. Let's see how adding this new culvert is going to affect the likely paths the water is going to take on that surface. So I'm going to toggle that layer off, and I'm going to go back up to our watershed analysis tool. I'm going to this time check the option to use vector features to modify flow. I'm going to make sure my culvert line layer is checked. I'm just going to run this very quickly here. And we're going to have a very nice comparison of a before and after running the watershed without that particular culvert feature, as well as running it with the culvert. So we can see immediately that our stream paths have been modified. We have a more major stream path this time following the culvert under the road and then draining out in this direction, rather than previously the stream path was kind of banking a right here and following that initial road up in this north direction.
All right. For our next tip and our final tip, Gus is going to be sharing a little bit about 3D printing.
Absolutely. Thanks, Meg. So we recently added support for a couple um, 3D model or mesh file formats that can be used in order to um, interact with or can be used as input for a 3D printer. So this is a little overview of a potential workflow that you could use if you wanted to create a 3D printed recreation of some terrain data. So the first step in that could potentially be to connect to one of our built-in online data sources. We have many publicly available data sources. For example, for worldwide coverage, we have the Aster GDEM. So you could connect one of these data sources and then export to a locally stored file. Once you've done that, you'd be able to then either, if you accessed some lidar data, you could create an elevation grid, or if you already have the elevation data, then you're good to go. Then you could, if needed, perform a little additional adjustment of that terrain grid. So, for example, maybe adjusting the vertical exaggeration, for example, so that you can prepare that 3D model layer. And then so once you have everything all ready to go, then you can export to one of our specified built file formats. So for example, the STL 3D printing, so you can export a mesh layer in that particular file format, taking publicly available either terrain or lidar data and creating an actual tactile output that you could create using a 3D printer.
All right. So without further ado, we are going to jump into the live Q&A portion. So, Gus, I don't know if you had a specific question that you wanted to start with. Otherwise, I'll just grab the first one, which is, can we undo the split layer, rejoin split sublayers?
Yeah, that's a great question. So in the contour tip and trick, we had talked about the ability to split layers based on a particular attribute value. And we use the feature type for this example. An easy way to get these layers all back into one combined layer is to copy and paste the features. So you would select all the features in a layer, then Control C, Control V, and you could copy them all into a new layer containing all of those features.
Awesome. Next up, I've got another question related to the contours. When you create contour lines from lidar and extract the contour lines out, can you export them as KML? Um, and which one would be better for quality?
That's a great question. So yes, so we support quite a few different vector file formats, both for import and export. So you could absolutely, once you've created your lidar derived contours, you could export those to KML or KMZ. You could also export them to a number of different CAD formats, for example, DXF or DWG, for example.
Awesome. Cool. So, next up, we have a cropping question, which is, does the crop have to be a box or can it be a shape?
That's a great question. So in the example I provided, I also wanted to just illustrate something that I use all the time, which is the ability to create the bounding box for another layer very quickly. But you absolutely do not need to use. You can use an irregular polygon. You don't need to use a regular polygon to crop a layer. So you can use any kind of irregular polygon to crop the bounds of a layer.
That's awesome. Now we've got a watershed question, and I believe that this is one of the last ones that we have. Um, Using the watershed feature with a modified stream flow, could further analysis be performed to show the potential floodplains that would result from such a change?
Yes, absolutely. So you could, thinking off the top of my head, further analysis in terms of the potential floodplains, you could potentially use the stream path maybe as a source to use our tool through which you can uh, simulate water level rise. So it's possible that you can also view the actual watershed areas. So you could view the potential drainage areas associated with each stream path and see how those drainage areas changed based on using the vector features as obstructions or culverts or not using them.
Awesome, thank you. So that about wraps up our Q&A portion. I'm going to jump into our next slide, which is about how to upgrade. So if you saw some tools that you haven't tried out yet, we definitely encourage everyone to get on the latest version because we're always improving some user-driven, um, projects, either features or, adding stuff that just makes it more usable for everyone. So definitely upgrade. This is how you would do that. Here's the download link, and then specifically, we have some more information about um, active maintenance and support, which enables you to license the latest version. So that is how you do that. And then we have a survey after the webinar. If you have been coming to our webinars and you want a little bit more say in what we talk about here, let us know what you want to see. So, you know, check that out and let us know your thoughts. And that's about it. So we've got another webinar planned for July 31st. Definitely join us for that. Otherwise, keep keep connected and write in with your questions. And that's about all we've got for you today. Gus, do you have anything else?
Just if anybody has questions, maybe you're on an older version and you're interested about what changes have been applied or added to the new version that might affect your particular workflow, for example, you can reach out to our support email. So geohelp@bluemarblegeo.com. I'm sure Meg can put that in the chat for everyone. So if you have any specific questions about, what's changed within the new version and how can it be applied to my particular use case, definitely feel free to reach out to us.
Absolutely. Please go for it, reach out to us, and otherwise, we'll see you next time. So, thank you so much. Bye.